Hello everyone, my name is Karim Fahmy and I'm the CTO of HyperPath. In this video, I want to go over what HyperPath is, what is the problem it's trying to solve, and to explain in some detail about how it works. So let's get started. HyperPath is a software solution that lets you combine or bond multiple unreliable internet connections into a single ultra-reliable and high-speed virtual connection. This can be very useful for individuals or businesses that require reliable internet connectivity in challenging environments, such as outdoor video streaming, connectivity under mobility like inside trains or in cars, or if you live or operate in rural or remote areas without reliable landline internet. HyperPath can let you combine any wired or wireless links you have, such as DSL, Wi-Fi, cellular, or Starlink, to obtain fiber-like connectivity wherever you are. However, what sets HyperPath apart from any other bonding solution is that it operates as a peer-to-peer mesh VPN. This means that your HyperPath devices can communicate with each other using bonded connectivity over minimum latency peer-to-peer connections, and without the need of a bonding gateway. It also enables you to use any of your own devices as a bonding gateway when connecting to a third-party server on the internet, allowing you to avoid speed and reliability limitations related to using shared servers, and consistently reach maximum bonding speeds. Additionally, it also keeps your data from going over third-party servers, increasing data privacy. But before I go into more details about how HyperPath works, let's discuss more clearly what is the problem that it's trying to solve. Let's say you're trying to have an important Zoom meeting on your laptop while using Wi-Fi. The Wi-Fi connection can fail for two main reasons. First, the wireless connection to the Wi-Fi access point can degrade due to interference from nearby devices that are using the Wi-Fi on the same frequency. Alternatively, your ISP may have an intermittent outage or capacity degradation at peak hours that can result in the available capacity reducing below what Zoom needs. In both cases, the result is a poor or unusable Zoom connection. Now, if you're like most people and you have a cellular connection available over your smartphone, you might decide to manually switch over your laptop to your phone's hotspot. And this may resolve the immediate issue, but this approach is far from ideal. First, you cannot use both links at the same time, which means that your Wi-Fi capacity is being wasted. This could have otherwise been used to increase the reliability or the quality of your Zoom meeting. Second, once you switch, your IP address will change, and this will cause the Zoom connection to reset, and that can take multiple seconds. Third, this is a reactive approach that relies on the connection first becoming unusable before you manually make the decision to switch over to your backup connection, making it very slow and disruptive. And this is what HyperPath can help with. HyperPath is a VPN client that will combine or bond multiple connections, allowing applications like Zoom to automatically leverage all your available connections simultaneously. In this example, when both the Wi-Fi and the cellular hotspots are active, the data sent by Zoom client will be split or replicated across both links, increasing the available capacity and mitigating any fluctuations in either links. If the Wi-Fi fails, there will be no disruptions to the connection since the traffic will continue on the cellular hotspot, and the IP address that Zoom sees will be that of the HyperPath bonding gateway, which will remain the same. The Zoom client will now simply only see the capacity of the cellular hotspot. And if the Wi-Fi becomes usable again, it will be seamlessly integrated back into the scheduling with no manual intervention needed from the user. HyperPath currently supports two data transmission modes, replication and aggregation. In replication mode, HyperPath will transmit copies of each packet across all links, and as long as at least one copy of each packet is delivered, it will be able to fully reconstruct the original message, making the losses transparent to the application. In addition to mitigating packet loss, this approach also mitigates latency fluctuations, since the first copy of a packet arriving at the bonding gateway is always immediately forwarded to the destination. In every case, additional copies of the packet arriving after the first one are discarded in order not to cause unexpected behavior in the application. In aggregation mode, HyperPath will split packets coming from the application across all available links in order to maximize capacity utilization and increase application throughput. In order to do this, it will dynamically estimate the available capacity across all links in real time and attempt to saturate that capacity by assigning a sufficient number of packets to that link each second. A unique aspect of HyperPath is that it's a combination of a link bonding solution and a peer-to-peer mesh VPN. What that means is that devices with the HyperPath VPN client installed will automatically discover and connect to each other over secure peer-to-peer connections, creating a virtual mesh topology. Devices with more than one network interface will create additional peer-to-peer connections over their other interfaces to all other devices. All peer-to-peer connections between any pair of devices are bonded into a single logical connection. This enables your HyperPath devices to communicate with minimal latency over the bonded connections. Furthermore, it allows you to use your own devices as a bonding/VPN gateway when connecting to third-party servers on the internet, regardless of whether your HyperPath devices have a public IP address or not. This gives you complete control over how much bandwidth is available at your bonding gateway, allowing you to reach very high bonded throughput. It also allows you to control the source IP address of the bonding gateway, allowing you to access services that would otherwise block data center IP addresses. However, we also offer managed bonding gateways that are available for everyone in cases where you don't have an appropriate device that can act as a bonding gateway when connecting to non-HyperPath internet servers. That's all for this video. In the next video, I will show you how to use the HyperPath aggregation capability to combine the speeds of two different cellular connections on a Linux machine. Thanks for watching.